All right, welcome back everyone. Today we are looking at 4.8a. This is our last section for chapter 4, and in this section we're taking everything that we've learned so far of solving with square roots, completing the square, the quadratic formula, and we're going to look at a topic that kind of keeps coming up: what happens when we take the square root of a negative number. So that's pretty much what all of this is about today. We're going to look at something called complex numbers, so that's when we have imaginary numbers and real numbers and kind of see what they do together. Okay. All right, so we talked about this in our last section with square rooting, and when we found our discriminant, every once in a while we would have a negative pop up inside there. And we've talked about, well, that results in a non-real solution, aka an imaginary one. Okay. And so what we're going to start doing, instead of writing imaginary every single time, what we do in math instead is we use this little I here. Okay. So whenever we square root something that has a negative, it results in an imaginary number. So if you square root -1, we would get 1i, or just I. Okay. So these first three problems here, this is kind of what your homework looks like. This is combining what we've done earlier in the chapter. And as you can see, we're square rooting all of these and they're going to be negative. So we know there's going to be an imaginary number inside of there. Okay. So if I cover up this negative here, we know the square root of 25 is 5. Reminder, something we have talked about. We always have to put the plus minus. Now because it is a negative 25, it's actually 5i, meaning they're imaginary. So plus minus 5i. Okay, so that's all we have to do for that. So a negative results in an I, an imaginary. 8 we know is not a perfect square, but we do know we can simplify it. So I'm going to split this between the square root of 4 and the square root of 2. We know the square root of 4 is 2, so I'm going to say plus minus 2. And square root of 2, I can't find that, so I'm going to put the 2 here. Now the I, it's going to go in the middle here, okay, because we have a negative, so we're going to have I. So when we do problems like this, ladies and gentlemen, always put the plus minus, number, I, square root, number. So that's kind of the proper notation that we're going to do in those. Excuse me, sorry. So that's kind of the difference between those two. What if you have one that's a perfect square like this one? And what happens when you have a non-perfect square but you can simplify them? So that's the difference between those two. Again, notice both of them have the negative, hence why we have the I. Now this one, again, very special. I see I have 7. We know it's not a perfect square, but also this one doesn't have a perfect square that goes into it. So really, I can't take the square root of 7. But I do have a negative in front here. So we do have a rule that never leave a negative inside of your square root. Okay, so if it's a negative, reminder, it's just going to come outside as an I, and we're still going to have the square root of 7. A reminder, whenever we take the square root of something, you're going to have a positive negative. So that's kind of the difference between these three problems. Whenever you have a negative, those will all come out as an I somewhere in your problem. If you're able to square root it like the first one, make sure you square root it. If you're able to simplify it, make sure you simplify it like this one. And if you're not, you still have to take out that I, put the plus minus in front, but keep the 7 inside. So that's the first part of your homework. You guys have been doing this the last few days. You're going to be fine. The only difference is you now have an I because of the negative. Okay. Some other things that we have talked about is solving. Now, back when we were solving, reminder, our goal was try to get it to say x squared equals a number. And then what we do is we square root both sides and we're going to solve. Now, some of these might have an I because you're trying to square root a negative, but reminder, whenever you are solving these, you always have to have that plus minus, because whenever you square root, you have a positive and a negative. Okay. All right, so let's review what we did last week. So on this one, trying to get this x squared on its own, so I'm going to minus the 200 from both sides. Okay, I'm left with 2x squared equals negative 200. And our last step, I'm going to divide by 2. We now have x squared equals negative 100. To get rid of my square there, I'm going to square root both sides. I'm going to have x equals, the square root of 100 is 10, but I see I have that negative, so I'm going to have positive negative 10i. I'm going to warn you on your test this week, I'm probably going to get some of you because you're going to start forgetting some of these things I've taught you, the plus, minus, or the I, so make sure you're not losing those easy points. So that problem is taking what we learned last week combined with this imaginary business. Okay. All right, let's do a couple more. I'm going to subtract 60 on both sides. Okay. We're going to divide by 3. And I'm going to have x squared equals negative 20. We're going to square root both sides to get rid of the square. Now this one, unlike our last one, 20 is not a perfect square, but I can split it between 4 and 5. Now again, we're making sure we're writing this in proper notation, so I'm going to say x equals. We are going to have the positive negative. The square root of 4 is 2, so I'll have 2i because of the negative, and we have the square root of 5. And that's our problem. Okay, see the difference between those two? One of them we're able to find the square root, one of them we are not. But both of them had the square root of a negative, so we need to make sure we are putting an I. All right, our last two like this, these two again have some special stuff. I'm going to add 50 to both sides. I'm going to take x squared equals positive 50, and then to get rid of our square, we're going to square root. Now I'm purposely putting this problem here because what starts happening is you guys get into these habits of like, well, I'm putting i's on everything. This one, I'm square rooting a positive. So this one, because I have a positive, there's going to be no I. So we're going to do how we did last week. I can take out a 25. 25 times 2 gives us 50. So I'm going to have x equals positive negative 5 square roots of 2. Again, no I because the number is positive. Okay. All right, our last one like this. I'm going to subtract the 24. I'm going to divide by 2. I have x squared equals negative 12. I'm going to square root both sides. This time I do have a negative. I also have a non-perfect square, so I have to split it between 4 and 3. Again, making sure you write it in proper notation. So I'm going to have x equals positive negative. The square root of 4 is 2. There's a negative, so I got to have an I, and the square root of 3. So on your homework, you're going to have a little bit of everything of this. You're going to have some that work out, some that don't. You might have some like this. If you got a positive, it means there's no I. Okay, that is the second part of your assignment. We have 2 problems left. Is it 2? Might be. Yeah, kind of. This right here will be most of your assignment. And then we have another thing we're going to talk about that we did last week. This one right here obviously looks very different than the ones we did on the previous page. These have 3 terms. So when we have 3 terms, there's a couple things that we have done. Okay, we have factored. So that's when you have answers like this. We have completed the square. That's when we have this. Complete the square. Spell it right, Bayles. And then we have our most special one that works every single time. We have the quadratic formula. Okay. So the quadratic formula, reminder, works for us every single time. So if you're not able to do factoring or completing the square, I'm always going to suggest to use the quadratic formula. Okay. So reminder, when we use the quadratic formula, it has to equal 0. Check. And then I'm just going to plug it into our formula. Here's our A, our B, and our C. So I'm going to say x equals positive 3 plus or minus negative 3 squared minus 4 times 2 times 5 all over 2 times 2. In front here, I'm going to have 3 plus or minus. In the side of the square root, when we plug that all in, our discriminant is going to equal negative 31. And on bottom, we're going to have 4. Just like how we did the first day we did the quadratic formula, we're going to leave it in this form. But something I'm noticing, something that I told you not to do on this first page, is that reminder, if you have a negative here, you cannot leave it. So that's going to come out front as an I. So our actual answer is 3 plus or minus I square root of 31. We can't do anything with 31. It's not a perfect square. Can't put a perfect square into it. All over 4. And that is our answer. So if ever you have a problem like this, always look to see, could you factor? Most likely not in this section. You can probably use the quadratic formula. Never leave a negative inside here. Always bring it out front as an I. All right. Our last thing is our easiest thing. It should take you just about 2 minutes to do. Our next thing we're going to talk about is something called complex numbers. They're called complex numbers because they are made up of 2 different types of numbers. You have your real numbers and you have your imaginary numbers. So whenever we are doing problems like this, when we write complex numbers, it goes real first and then imaginary. Okay, so today what I'm going to have you do is I'm just going to have you add and subtract complex numbers. Okay, when we do that, we are going to combine like terms, which is something you guys have probably been hearing since like 5th grade. So when we do that, we combine our real numbers together and combine our imaginary parts together, so aka our i's. Okay. So if I look at this first example, I see I have a plus here, so that means we're going to add these 2 things together. Reals go with reals, imaginaries go with imaginaries. So I have 4 plus 5, so we're going to have 9. I have 3i and negative I, so when I combine those, I'm going to have 2i. We cannot combine them because we have reals and i's. They're not like terms, so that is our answer. Do you see how this today is going to last you? It's going to take like 2 minutes. This next one is probably our most challenging. This is where I'm probably going to get some of you on your test this week. When we have a negative out in front, this means we're subtracting, but it also really means this minus goes to all of this. Okay, so now it means this 3 is really negative and this 5i is really now positive. So just be aware of that. When you have the negative, it has to go to both of those, and what it really means is it changes its sign. Okay, now what we're going to do is combine like terms, and again, real numbers go first, imaginaries go last. So I have this negative 7 and this negative 3, and when I combine those, we are going to get negative 10. I have this positive 2i, and we just distribute that negative, so this 5i is now positive. So when I combine those, I'm going to have 7i. We are not able to combine those, so this is our answer. Okay. So our main concepts today, if you want to kind of write stuff down on the top of your paper, reminder, if you have a negative, it really just turns into an I out in front. Oh, what? Why am I writing another negative? It comes out as an I out in front. Never leave a negative inside there. Proper notation, you would write it as number with a plus minus out in front, an I, and square root to be in proper notation. And the other thing that we talked about, you always go reals and then plus your imaginaries for your complex numbers. So those were our main concepts today in our video. All right, thank you. I'll see you tomorrow.